Alright, what's up, everybody? Happy Sunday. So, last time, lots of new developments happened. I added channel point rewards. I set up my Discord, which is now, I think it's a link underneath, but you can also do !Discord in my chat. But I also wanted to show this again. My second piece of artwork. Hey Snake Star, how you doing? Miskomin coming in hot with the second artwork of me. Super impressive. Can't believe it. And I'm not entirely sure, but I'm pretty sure Miskomin's not even one of my actual students. So this is just some random person. But yeah, Discord is up and running, so feel free to join. And I think today, I want something easy. So I'm gonna go over the paper 2 of the paper 1 that I did last time. Nutter butter, reminding me to hydrate. I've also updated the rules and stuff, or channel points. So there's a little bit of cooldown on hydration. Some things are worth more points than before, specifically wearing a hat, because that one's kind of dumb. But anyways, the sooner I get this done, then I guess then I'm done. How was your test, by the way, Snake Star? I saw in the Discord you said the questions were easy. Alright, what is this? We have 35 students. Some are in class A, some are in music class M. 5 don't take either. So then here's the Venn diagram. Went well actually? Oh, nice. Oh, trig derivations? Isn't that just like sine becomes cosine? Alright, let's see this. Write down the number of people who take the art class. Well, that's all the people in the art class circle, which is 11 and 16. Well, it sounds like you did well, so that's a good thing. So there should be 17 people that take art. Now, let's see. One student out of this entire group is chosen at random. And we need to find the probability that that student does not take an art class. Okay. So there's 35 students, so we know that this is out of 35. LT orange juice, thanks. And, well, how many students don't take art classes? There's a couple ways we can do this, but we do know that there's 17 people that do take an art class, so 17 minus 35. Oh yeah, this is a paper 2, so I can use a calculator. Where's my calculator? Oh, here it is. Okay. So 35 take away the 17 people that take art means that there's 18 people that don't take art. Okay, let's see. Find the probability that the student takes either art class or the music class, but not both. So out of 35, we need to make sure that they take either the art class or the music class, but they can't be both. So you just do 11 plus 13, which is 24. Easy peasy. They even give you a second page to do work for the first question. So, I feel like I should repost my stream on Twitch. Or not on Twitch, on the IB subreddit. Just because I feel like I checked out the subreddit the other day, and there's a lot of people asking for math help actually. So, I don't know. Maybe I should re-advertise myself there. But I don't want to be like that person that just like keeps reposting like, hey, check out my channel. So maybe I can get one of you guys to do that. r/IBO. Hey guys, I found this IB math teacher that streams online. He seems pretty good. You guys should follow him. Because, like, I'm an affiliate now, which is great, but they do have a higher tier, which is partners, but I don't think that's honestly possible because you need an average of 75 viewers each time you stream. And I really don't think that's possible for the nature of my stream. Even though, you know, I'm sure there's like more than 75 English-speaking students that need help, that have access to the internet. So maybe I should just advertise more. Nutter butter again with the hydration. Anyways, I don't even need to look at this problem. It's a linear regression equation, so let's put this into our list. Excuse me. Okay, so let's see. We're gonna put in these values. So 21, 21.9, 21, 20.3, and then 20.8. And we're gonna go over to the second list and put the y values. 178.3. Whoops. $185, 177.1, 169, 174.6. Okay, so then now we can go back to stats and then calculate the linear regression. So here are my coefficients. A is 9.91, B is 31.3, negative 31.3. So there's A, there's B. And then write down Pearson's correlation coefficient, and that's 0.986. Which is an extremely strong correlation. So this is basically linear. Snake Star, how do you derive sine 2x and 2 sine cosine x? Aren't those both the same thing? Wait, yeah. Well, okay, first, are you aware of chain rule? I mean, you should be at this point, right? Yeah, so if you want to take the derivative of sine 2x, you take the derivative of the sine part first. So that's cosine 2x. And then you need to take the derivative of the inner function, which is 2x. So this gets multiplied by 2. So you get 2 cosine 2x. Whereas if you want to use the identity first and then write it as, well, that's as far as you can go, right? Is there like more to this than just taking the derivative? I mean, you could use the double angle here, I guess, but Yeah, I had to prove that they're equal. I see. Okay, so let's just... Why don't we work with this? We need to take the derivative of this anyways. So we'll need to use, what, product rule? Versus chain rule over here. Because we have sine x times cosine x, so this is just going to become... Well, we'll leave the 2 out. And then we have the derivative of a sine, which is cosine, multiplied by just whatever this is. So that's cosine times cosine. And then we're going to add the derivative of cosine, which is negative sine. And we're going to multiply it by sine. This is product rule. So what I end up with is I end up with a negative sine squared x. And then hopefully you can see how these two are the same thing. And if you don't, then check your formula book. Yeah, product rule. You have some sort of x times this another sort of x. Okay, so what is this now? So we have another athlete whose hand length is this. Use regression to estimate his height. So this is the x value, and then all we do is we plug it into here using the appropriate coefficients. So that was 9.91 times our x value, which is 21.5, minus 31.3. So 181.725. Easy peasy. Okay, next we have a rational function. Yes, r squared times another r would mean r to the power 3. That's kind of what it means. So here we have a rational function. We can't have x be negative 3 over 2 because if we plugged it in, we would divide by 0 in our numerator. So what can we do? First, we can find the y-intercept. So y-intercept is when x is 0. So if we were to just plug in 0, I get negative 1 over 3. So that's my y-intercept. The equation of my vertical asymptote, well, they gave it to me. That was in my domain restriction. And then the equation of the horizontal asymptote. So that's just the coefficient of the x's, so 6 over 2, which becomes 3. And then, hence or otherwise, write down the limit as x goes to infinity of all of this stuff. So essentially this is just asking in a different way, what's the horizontal asymptote? So this limit is 3. So I think that's it. And if you don't believe me about this limit stuff, well, let's just go to Desmos. So we have 6x minus 1, 2x plus 3. And let's call this our function. And what I'm gonna have is, I'm gonna have a slider. Where's my slider? There it is. Okay, add a slider. And let's just make a go from 0 to infinity. Because what I'm going to do is I'm checking the limit of the function as it goes to infinity. So what I can do is I can start at an x value of 1 and then drag it up to a decently large sized number. Now, basically, if my a value is 0, then the value of my function is negative 0.33. And then as I drag this and get it larger and larger and larger, we are trying to observe the value of the function and try to see its limit. In other words, what it's trying to head towards. And you can see it's getting closer and closer to 3. And that's literally what a horizontal asymptote is. It's you take the limit as x goes to infinity or negative infinity. So you can see over here, as I go towards infinity, so I keep going to the right side, my graph gets closer and closer to the value of 3. And then now, like, we're not even that far in. I'm at like 126, and they're basically almost overlapping. Of course, if I zoom in, then it's not quite there, and then I can just keep dragging to the right. But anyways, this is just another way of asking what's the horizontal asymptote. Okay, let's see. We have a classic kinematics problem. So I have my velocity here, given by some function, between 0 and 5 seconds. And then we need to find out when the particle is at rest. So being at rest means that the velocity is 0 here. You don't like arcs and sectors, but they're so easy. You just do like 2 formulas. Okay, and because it's a paper 2, then I can just graph my actual velocity function. And I'm going to change my window because they already told me the domain is from 0 to 5. So I just like to give an extra unit on each side of my boundaries, so from -1 to 6. And then I need to change my y values. I have no idea what this is going to look like, so I'm going to go with the default, which is -10 to 10. Okay, so you can see that my particle is going to be at rest right here, so I can calculate the 0. So put my cursor on the left side, put my cursor on the right side, make an estimate with my cursor, so right there, 2.95. So by my GDC, the particle will be at rest at 2.95 seconds. Okay, next up we want to find the acceleration. And to find the acceleration, that's the derivative. So we can just put this into a calculator. Oof, LT Orange Juice with a very complicated question. Am I familiar with the Dirac delta function? Unfortunately, I don't think so. LT orange juice. This is some post-secondary stuff, isn't it? It sounds familiar to me, but I haven't done post-secondary math in like 8 years. So let's see, Dirac delta function. Yeah, unfortunately, I don't think so. At least, not with my current knowledge. But you know LT Orange Juice? We do have a math specialist. He's not here in the chat, but if you join the Discord, you can add him. His name's RGPT. So he's over here somewhere, right here. He's even online. Yeah, Snakestar will add him. But feel free to join, and then you can post in the math help questions. Because he's actually working on his master's in math on his way to his doctorate. And he's pretty good at math. Better than me. Yeah, sorry I couldn't help you, but just a little bit beyond what I can do. The Discord link is broken? Oh, just do !_ Discord. And then here's the link. And it should be good. Let me know if it's not though. So meanwhile, I need to calculate this. So I can do second, calculate, and we do have a derivative function. And then I can just state my x value being 2. So there it is. My acceleration is 0.659. Meters per second squared. Okay, and then find the total distance traveled by the particle. So I've said this a few times, but of course not everyone's gonna watch every single stream. But my velocity function looks like this, kind of. And basically, if you were to take the integral, because finding the distance when you have the velocity is related to taking the integral, you have two different areas. You have one below the x-axis, and then you have one above the x-axis. So, of course, if you think about what it means to be below the x-axis, this is, again, a graph of the velocity. This means I have negative velocity, so I'm moving to the left. So this area represents how much I've moved to the left. And then I come to a rest, because you need to stop before you start heading towards the right side. So this area represents how much I moved to the right. So unfortunately, you can't just take a straight integral from 0 to 5. What you can do is you can take a straight integral of 0 to 5 of the absolute value, because graphing calculators are more than able to do this. Because what this does is you're taking the absolute value of the graph. So all of this stuff just becomes positive, and it has the same size area. And then when you integrate from 0 to 5, then you're just adding this area and this area together, and they don't cancel out like these two areas do. Because this would be technically a negative and this is a positive, so when you add them together you get a smaller number. So total distance, do the absolute value. Way easier. Of course, the second way that you can do it is you can split the integral. And you can calculate the left, going to the left portion first. That's kind of why they asked you part A, where you find out where it does split, because it's going to stop at 2.95. Yeah, piecewise. This is generally how they teach it. And then of course this thing is negative, so then you will need to multiply by a negative so that it turns positive. And this is probably how you would do it if you weren't allowed a calculator and this was, you know, easily integrable. But because, you know, we do have a graphing calculator, this is way more efficient. So all I gotta do is go back to here and then make sure I add in the absolute value. Oh, whoops. So 1.4 to the power of x minus whatever this was. 2.7. And then I'll just get rid of this stuff. Ooh. Delete. Yeah, so you see we took the absolute value. And then this one, easier to integrate, because now I don't have to break it up into pieces. So my lower limit was 0, my upper limit was 5. And there you go. And there's the total distance traveled, 5.35. And that seems about right. Nice. So, LT Orange Juice, what year of math are you in? Because I'm assuming you're in university. And what course is this Dirac function for? Because I'm not gonna lie, I'm pretty sure I've learned it. I just don't remember it at all, besides like the name. Okay, let's see. The sum of an infinite geometric sequence is 33.25. The second term of the sequence is 7.98. Find the possible values of r. Okay. So we do have two formulas we can rely on. One is the sum of an infinite geometric sequence, which is just, you know, the first term divided by 1 minus the common ratio. And then the other one is, I know that u2 is u1 times my common ratio. So this thing is 33.25. And this thing right here is 7.98. Okay. And then essentially we have a system, right, of a two equation system with variables u1 and r. So here's my first equation, and then here's my second equation. So then now we just solve the system. Lots of ways you can do this. Of course, knowing that we have a GDC, what I can do is I can just essentially graph these. But first, let's make them in proper function notation. So from equation 1, I can say this. And then from equation 2, I have this equation instead. So essentially these are going to act as my x's and y's. And then I find their intersection. So this one over here, 33.25. The last question I did last stream from that paper was on your midterm. The last question. This one, right? What was the last question? I thought it was a probability question. Oh, it was this one. This one about P and Q? Did you remember how I did it? Nice. Well, hopefully you remembered how I did it, and this was hopefully no issue for you. That's 16 free marks then. And I did it much faster than you did? What? But, well, were you paying attention when I was doing this one? Oh, you did your midterm before the stream. Oh, I see, okay. Well, I mean, it's kind of to be expected that I should be able to do this faster than you. Otherwise, that'd be kind of sad. Okay, so here's my graph of the two. So this reciprocal one is obviously the second equation, and then this one is a linear graph, so that goes straight down like here. So you can see there's going to be an intersection somewhere over there. I can change my window and try to focus in, because I know that this is going to be somewhere between 0 and like 3, and I don't know, like a minimum of 5 and a maximum of 20 maybe. So here, I'm gonna change my window some more. Because I want to see this clearly. Because I think there's actually two intersections. Yeah. There you go. You see there's two intersections. And I'm gonna cheat because I don't like doing those functions in a graphing calculator. Because Desmos, I can just click on them. So here's the first one, 0.6 and 13.3. And it's not like you can't do this on a GDC, it's just, that's a little tedious right now. And then there's another intersection somewhere over here at 0.4 and 19.5. And again, just think about which variable is represented by x coordinate and then the y coordinate. X's are my r's, and then the question just wants the possible values of r. So there they are. My two possible values, 0.6 and 0.4. Okay, what do we got? Binomial expansion, it seems. So the coefficient in the term that has x to the power 40 is 5 times the coefficient in this term. Find the value of k. Why are they doing this? Alrighty, so what do we got? If we were to use the general term formula, then this is 12 to the power of something, r. And I'm talking about r for this one. I guess I'll call it r1, because there's going to be two different r values related to the x to the power 40 and then the x to the power 38. So this is the general term for the x to the power 40, and this needs to be something, some constant coefficient, times x to the power 40. Okay, so what we can do is we can help see what r is going to be, r1, because I know that when I multiply these exponents of x together with these exponents of x, I should get x to the power 40. So looking at my x's, I have x to the power 4 to the power 12 minus r1, x to the power of 2 to the power of r1, and then all of this should be x to the power 40. The team's assignment is calculator, right? Some of them. If you check your answer key, if it's not in a decimal format and it's an exact value, like pi over 3, then this means that you should have used a special triangle. But if your answers were in a decimal, then that means it's calculator. Okay, so all we need to do is use our exponent rules and combine these all together. So I need to multiply 4 with 12 minus r, so this becomes 48 minus 4r. And then likewise, the squared multiplies with the r1, and then these add together. So minus 4 plus 2 makes minus 2, and then now I know that these two exponents are equal to each other. So we can solve for r1. So r1 clearly has to be 4, right? Because 2 times 4 is 8, and then 48 minus 8 is 40. Nice. Okay. So next up, we need to repeat this process, and I need to find r2. So here we go again. Copy. So because it's the exact same formula, right? It's just a different r value. It's r2, which is related to the x to the power 38. Then I just change the r1s into r2s, and I also change x to the power 40 to 38. But all of this stuff is exactly the same, right? The only difference is now this is equal to 38. In other words, R2 is equal to 5. Okay, so what's the point of finding R2 and R1? Because we need to find the coefficient, right? And to calculate any sort of binomial coefficient, I need to know, the NCR. So I need to find out the second one. Okay, so the coefficient C comes from a number of things. Obviously, it comes from Pascal's coefficient. It also gets multiplied by a 2 to the power of r minus 1. And then there's this factor of k as well, 1 over k. So all three of these multiply together to create the coefficient for x to the power of 40. So in other words, 12CR1, which is 4, times 2 to the power of 12 minus R1, which is again 4. So 12 minus 4 is 8. Multiplied by 1 over k to the power of 4. So this is the coefficient for x to the power of 40. Okay, how does this help us solve k? Well, we know what this is equal to, because it says that it's 5 times the coefficient of the x to the power 38 term, right? In other words, this is 5 times the coefficient of x to the power 38 term, so so this is the coefficient of x to the power 38. And then let's simplify a couple of things. 2 to the power of 8 is going to cancel with 2 to the power of 7, leaving just the power of 2. Likewise, 1 over k to the power of 4 will cancel out with some of the 1 to the power of k in the power of 5, leaving just this. So what do we have so far in our formula then? I have 2. On the left side, 12C4. And then on the right side, I have 5, 12C5. Times 1 over k. And I'm trying to find out k, so this is easy enough, right? I multiply k over to this side and then divide, multiply k over here, divide, and then divide these over here. So this implies k is 5 times 12C5 over 2 times 12C4. Okay, and then you can put this into your calculator at this point to calculate the actual number itself. But let's see how far we can take this before we need to do anything in the calculator. Using your formula book, 12C5 is defined as 12 factorial over 5 factorial and 7 factorial. This is 12 factorial over 4 factorial, 8 factorial. You know what? Not worth it. I'm just going to put this into a calculator. And then this should be k. So 5 times 12 C4, or no, that should be C5. Divide this by 2 times 12 C4. And I get 4. That's convenient. Yeah, this one's pretty tough. It's not your typical binomial expansion, because normally they just ask you to calculate the coefficient. But hopefully this made sense, what I was going through. And if it doesn't, I don't know. Go rewatch the VOD in slow motion. Half speed. Okay, this does not look fun. So a communication tower T produces a signal that can reach cellular phones within a radius of 32 kilometers. So there's a tower here, and this is its signal range. The following diagram shows a line representing the road and a circle representing the area of the signal. Point R is on the circumference of the circle, and points S and R are on the road. The point S is 38 kilometers from the tower, and then RST is 43. So then all of this is here. So like you're driving down a road, and then when you're here, you're 43-degree angle to T, and then you can keep driving through the area. Anyways, whatever. Let SR be X. Use the cosine rule to show that x squared minus this stuff plus 420 is 0. Okay. So we know that S to R is 8, not 8x. And what we can do is we can create a non-right triangle. And luckily this is the radius of a circle, so then that's 32. And we know that this side is 38, so we can use Cosine Law, I guess, to show this. Okay, so how do we use cosine law? Unfortunately, as it is, we can't use cosine law because normally to do cosine law, you either need all 3 sides, which we don't have, or you need 2 sides with an angle in between them, which I don't have. What I do have, however, is I can use sine law with 32 and 43, and then I can use that together with 38 to get this angle. And then when I have this angle, I can calculate this angle, and then I can use cosine law. So that's the plan. I need to find out this angle first using sine law. So this says that sine of that angle over 38 should be equal to sine 43 over 32. So that means that my angle theta is the inverse of sine of this stuff times 38. So we can do that in a calculator. Well, first let's make sure I'm in degree mode. Okay, so this angle is 54.1. So now I can figure out this angle in between 38 and 32, and then I can use cosine law to finally get x. So 43 plus 54.1, subtract 180, so 82.9. Now, is this actually what they want me to do? Because I need to show this, right? So cosine 43 needs to pop up. But the issue with that is I'm going to use cosine 82.9. You know what? Forget it. I was too focused on using cosine law to solve for x, when I can just use cosine law like this. And instead of saying that this is, and then this is just there, because fine, yeah, okay. We have our side, we have our side, we have an angle in between. We can use cosine law. So this means that 32 squared is equal to 38 squared plus x squared minus 2 times 38 times x times cosine 43. I got lost in the sauce. Okay, and then I'm sure if you rearrange this, you'll get this. Right? 2 times 38 is the 76, so all of this stuff is right here. There's your x squared, right here. And then I'm sure 32 and 38 squared, they make 420. So that's probably right. So this becomes this. Okay, hence or otherwise, find the total distance along the road where the signal from the tower can reach the cell phones. Hence or otherwise, find the total distance along the road where the signal can reach the whatevers. So they want me to find this. This distance. Okay, well, it says hence. So when IB says hence, that typically means that you need to use your former answer or whatever information's given to you up here. It says otherwise, which means of course you could do it without, but we're gonna take this as a hint. And what I can do is I can solve for x in this equation. So I can get the total distance from S to R. And then we'll see what happens from there. So x squared minus 76 cosine 43 x plus 420. I'm going to decimals again. So x squared minus 76 cosine 43 x plus 420. So I have 16 and I also have 26. Okay, so clearly we have an issue because there's two answers. And there should only be realistically one distance from S to R. I wonder what this means. Okay, let's double check everything. This is the distance x. And then using cosine law, I know this is true. Which leads to this, which leads to two possible distances. And then what if it is 16? You know, when in doubt, that's what checking the answer key is for. Question 7. Okay, my values of x aren't even the same. Did I type this into my Desmos wrong? Oh, am I not in radian? Or am I not in degree mode? Degree mode. Okay, 9.02. And 46.5. 46.6. Okay, so my hunch was I subtract these two x values. I don't see why that makes sense though. But apparently that's also what the answer key said you should do. I have no idea. So are they assuming that this is one x value and then this is the other x value? But then that doesn't make the diagram anymore. So like look at their answer key, right? So part 1 is very straightforward. You just use the cosine law on this triangle I drew. And then you end up with this expression. And then you can get the correct values of x. And then it just says here, you get 1 mark for realizing you just subtract the x's. Of course you can use Sine Rule too, but I wonder why this is the case. Oh, this is probably why. This is pretty crazy. And I don't even know if this is the right explanation. But I think due to symmetry, you have the exact same triangle over here. Or not necessarily symmetry, but there is another triangle with the exact same setup. And maybe these two different x's represent these two different values, and then if you want to find out the green line, then that's the difference between the two, maybe? That's pretty crazy. I don't even know if that's the right explanation, and if that even makes sense, but I'm just gonna go with it. That's a mean question. Like, what you also could do is, to figure this out, this is the sine rule thing. If you want to find out this distance right here, what you can do is you can firstly try to use the radius, yeah. You can use sine law with this outer triangle over here. And you can find out this angle. And when you have that angle, that also means you know this inside angle. And then from here, you can use sine law. Well, this is an isosceles triangle. So once you find out this angle using sine law, you know this angle. And then you know this angle. And then you can find out the bottom piece. Yeah, that's probably the other way in the answer key. This one's pretty crazy though. Like, before I looked at change the answers, I thought about subtracting, I just couldn't think of why. And I guess the fact that there's another triangle over here, yeah, who knows. Tough question. I think it was only worth 6 marks too. That's ridiculous. Okay, so section B, the first question is a vector question. Again, the new analysis and approaches curriculum. Excuse me. This is removed from the SL curriculum. So I don't feel necessarily like I need to necessarily do this for SL watchers. So I'm gonna skip it and save myself 16 minutes of work. Alright, what is this? Yeah, the old curriculum was a little tough, I think, personally. And that's part of the reason why, you know, for the other SL courses, or other IB courses, they've canceled papers. For example, I think history, they've canceled paper 3 or something. Science, they've canceled paper 3. But nothing's been canceled for math. And that's because they've just cut out a lot of stuff from the curriculum, so they didn't feel like they needed to, which is kind of stupid. But, you know, IB's stupid. But good for you guys. You don't have to learn more than you have to. Okay, what is this? Study on reaction time on 2 different age groups. Some are the ones less than 40 years old, and they have this reaction time standard distribution. So always draw your picture. So the average reaction time is 0.49, and then there's a standard deviation of 0.7 seconds. Okay, and then we randomly select someone, find the probability that their reaction time is greater than 0.65. So this is easy enough to do. We just put into a calculator. So in our distributions, we look at the normal CDF, and the lower bound is the 0.65 second reaction time. You never uploaded my review package. Oh, I should. Oh, Max, thanks for the subscription. Yeah, I should do that soon. Can you just leave a notification on Teams so I'll see it tomorrow morning? Okay, and then there is no upper boundary, so just pick some absurd number, it'll work out. And then our average is the average reaction time, which is 0.489, and our standard deviation was 0.00 seconds, 0.07 seconds. So we can calculate it, and there's our probability of having a reaction time faster or slower than this. So this little area over here is 0.1, 0.01, 0.07. Alrighty. And then we have the second group, which has a different distribution because they're older, so, you know, their reaction times aren't as good as younger people, which sucks, but that's the fact of life. And then we do know their mean, however, we don't know their standard deviation. And then we do know that the probability of their reaction time being greater than 6.5 seconds is this probability. So they already have given us the probability. And we want to find the standard deviation. So this is a pretty standard question. If you need to find the value of standard deviation or the mean, because those are things that they don't give you, then that implies that you're going to need to do a standardized normal distribution. So for part B, we are going to standardize this. So again, I know the probability of someone in group Y being slower than 0.65 seconds, or taking longer than 0.65 seconds to react. This probability is 0.396. And then if I standardize it, it's still the same probability. However, the boundary changes, and it changes to a z-score. So what that z-score is it's your y-score minus the average y, or I guess the average, divided by standard deviation. So 0.65 minus 0.592. So which is 0.58. Okay, now what's the point of standardizing? When we standardize, any normal distribution, the standardized one always has a mean at 0 and a standard deviation of 1. So that's really useful because then we can use inverse functions. So if you go to inverse normal, right, it's going to ask you for the mean and the standard deviation. So as a y variable, we don't even know the standard deviation. That's the whole point of the question. So you can't use inverse normal. However, after we standardized it, we can use the inverse normal, and that returns to us the z-score. And then we can equate the given z-score from the calculator with the expression for the z-score from the z-score formula. And then you can solve for theta or sigma that way. Okay, one thing to note though is, first off, inverse norm requires an upper boundary. This is a lower boundary. So we change this to upper boundary, which is of course 1 minus. So we change it to an upper boundary of the z-score, and then that's just the complement, so 1 minus that. So my area is 1 minus 0.396. And again, standard deviation and mean are 0 and 1, not necessarily in the order that I just said that they are. So here's my z-score from the inverse normal. So 0.2637. Dot dot dot. And I know that if I take this number and divide by the standard deviation, I should get this. So now I know how to get the standard deviation. I take this number and then I take 0.058 and divide by the answer. And there's my standard deviation, which is 0.220 if I round it to 3 sig figs. Alrighty, now let's see what's going on. In the study, 38 of the participants are in group X. A randomly selected participant has a reaction time greater than 0.65 seconds. Find the probability that the participant is in group X. Okay. So we want to find the probability that you're in group X, and they've given you information. So this is a conditional probability. They've given you that the reaction time is greater than 0.65 seconds. So we just follow our formula. Hello, Vincent. I hope you're having a good weekend. It's okay. Can you go over the process for number 9 in the trigonometry assignment if you don't mind? And Serpent was just about to ask that. Sure, I can go over that after I finish off this question. So in this one, So here is the formula, and we need to calculate this. Now, you have to be very careful with each part of this because there's a lot of intricacies. Let's first break this down into a visual, right? Your group is split up into, people of X and people of Y. And then it says that there's 38% are in group X. So that means that the rest of them, which is 62%, are in group Y. Now, these are split up into their reaction times, right? The people that are more than 6.5 and the people that are less. So more and less. And we found out the probability of each group being more than 0.65 seconds of reaction time. First off, they give you the group Y one. It's 0.396. So this is 0.396. And then we calculated this one. It's 0.0107. Okay. So to find out the parts of these, to have a reaction time greater than 0.65, well, you're either in the group X and you're slower, or you're in group Y and you're also slower. So first we need to find out each one of these probabilities. So that's 38% times being slower. And over here, it's 62%. And the reaction time for that group. So these all go into your calculator. So 0.00406 or something. And then 24552. Okay, so the probability of your reaction time being slower than 0.65 are these two probabilities added together. So my denominator is just those two added together. And then the numerator in my formula, well, what's the probability of being in group X and also having that slow reaction time? We already calculated that. That's this one, right? This is the probability of being in group X and being slower than 0.65. And then there you go. This should be our answer. We put this into our calculator. So 0.004066 divided by the same number plus 0.24552. So 163. Okay, so then my students have asked me to go over some homework questions. Question 9, right? I gotta open up my phone for this. Wait, if I show this, it's gonna be reflected, right? Can you guys even see that? Okay, you can't see it, but out of the 21 students I have, and this assignment is due at midnight, guess how many have turned it in? None of them. Shame on them. No, I don't care, but it's just funny that it says 0 out of 21. Oh, I don't know when I chose the due date. That's some random thing. Okay, so you have this, right? And then there's a couple of things. The first thing being is that it's no longer just cosine of an angle, it's cosine 3x. And I didn't do an example like this one because I just didn't want to take that much time. But what you can do is, if you don't feel comfortable with having a 3x, you can just make a substitution and just say that theta is 3x. So hopefully this looks a little bit more familiar to you at this point then. Okay, so what we're going to do is we're going to try to isolate cosine, as I mentioned in my lesson. So I'm going to subtract the 2 from the right side, so it becomes -3 on the left side. I subtract the cosine on the right side, so then it becomes 4 on the right side. So basically move the 2 over here, move that cosine over here, and then you get this. So essentially this says that cosine of your angle needs to be -3/4. Now, of course, this is not a special triangle, so we are going to use inverse cosine to get the reference angle. And this question is in radians, so just make sure that you are in radian mode. So 3/4 our cosine, and then you get 0.723. So that's my reference angle. And then the negative determines which quadrant theta is in. Yeah, and then we'll divide by 3 later. And then that leads to some trickiness. So again, it's not a big deal if you guys couldn't do this question. Okay, your cosine is negative, so according to our quadrants, add sugar to coffee. Negative cosine is not going to be in these two quadrants, so it's in this quadrant and that quadrant. So these are my two theta answers. So theta 1 is pi subtract my reference. Theta 2 is pi add my reference. So pi minus 0.723, and then you get 242. And then you get the other one. I have too many calculators open. Pi plus 0.723, which is 386, let's say. Okay, I actually tried to do a quick scan, and then I didn't actually want to choose these questions, so my bad. Okay, so then here are your answers as thetas. So we can do what Vincent says, and then basically, essentially, because this is 3x, each one of these is actually technically a 3x, we divide by 3. And then you get some answers. But you have to be a little careful, there's actually more answers that pop up. So once we're here, you actually, before you resubstitute as 3x, we write the general form. The general solution. So the general solution for all of theta 1s is 2.42 plus multiples of 2 pi. So then that means that 3x is equal to 2.42 plus 2 pi k. So we need to divide the general solution by 3. So if we do that, you get 0.807 plus 2 over 3 pi k. So why do we do this? Because look at our domain. We want answers that are between negative pi and 0. So my first default answer doesn't work, right? This is above 0. So I need to, do my general solution and then subtract 2 pi k from it. But 2 pi k is related to the theta answer. So we write the general formula, then we do the substitution, and then we divide everything by 3. So if I want to find the appropriate x that's related to the arm in theta 1, I need to take 0.07 and then I need to subtract 2 pi over 3k, not 2 pi, because 2 pi is related to the theta answer. Hopefully that makes sense. So that's why you need to do it before. So 0.807, and then I subtract 2 divided by 3 times pi. So there you go. Negative 1.29. So then I say k is negative 1, and then x is negative 1.29. The name Luca Cool is censored? Really? So does that mean that no one can @me in my Discord? You need to kick Dinobot. Okay, let me tag my mod. Yo, you made my name a banned word so no one can at me. Fix that. Maxime's one of my mods. He's the one that made the Discord channel, so he'll deal with it. Okay, so hopefully that explanation makes sense, why you need the general form, and then you divide it by 3, because then your general formula changes. Let you take a picture. But you can just rewatch the recording. Too much work? Have you taken your picture yet? Okay, and then we repeat the exact same process for the theta number 2. So 3.86. And then, yeah, if the other question in question 9 is like, you know, it has something that's like a multiple of x or whatever, then you do the exact same process. But again, this is 2 pi k, which means that x is going to be plus 2 pi over 3k, and we divide this by 3. So 386 divided by 3, which is 1.2729. And then again, the appropriate x for our domain is to negative pi. So then I subtract, again, a 2/3 of a pi. So subtract 2/3 of a pi. So negative 0.8. Negative 8.08. 808. Yeah, okay. I don't know why it became pointy. Okay, and then one last thing. You may have more than 2 answers, because now we're not adding, we need to keep subtracting 2 pi's over 3, and then whatever number results, or whatever number happens, as long as it's, you know, in between these 2 numbers, it still counts as an answer. So you might have more than just these 2 numbers. You need to keep subtracting 2 pi over 3's until you're out of the domain that they've given you. So hopefully that makes sense. So if you check the answer key, I think they have more than 2 answers. So their answer has this one, right? Negative 1.29. It has this one, negative 0.81. And then they also have a second answer, or a third answer. And that comes from taking this one and then subtracting another 2 pi over 3. So again, starting here, which is this answer, if I subtract another 2 pi over 3, I get 0.29, negative 0.29. So, and then you repeat, you get negative 0.29. And again, we know that this is in the domain because the domain is negative pi, which is negative 3.14. So we actually have 3 answers. If I subtracted another one, I'm out of the domain. Likewise with this one, 1.29, if I were to add, or sorry, subtract another 2 pi over 3, I'm out of the domain. I'm over negative 3.14. So there's actually 3 answers. One from the first theta one, and then 2 from the other, from theta 2. So does that make sense, you two that are paying attention to this question? I'm not asking you, Innocent. You had your chance to try to understand this last year. Well, actually, you'll have your chance again in grade next quarter. Yeah. Snake Star, you should understand too. This is trigonometry. Rip Edison? What about you? Yourself, Honey Key. Okay, continuing back with this question. Okay, 10 of the participants with reaction times greater than 0.65 are selected at random. Find the probability that at least 2 of them are in group X. I sort of remember this stuff. Is there a long lesson tomorrow or mostly practice time? Mostly practice time. I would like you guys to really understand this stuff. Trig in the unit circle before we move on. Okay, so this one. So this one is such a typical IB style question. You start with a normal distribution. This one even has 2. And then this very last question. This very last question, it actually switches to a binomial distribution. Because what you're trying to find right now is out of 10 participants, what's the probability that at least 2 of them are in group X? Will I give another package tomorrow? I don't know yet. I haven't thought that far ahead. I'll figure it out once I get to school tomorrow. So, in part C, we found, it was complicated, but essentially what we found is, what's the probability of being in group X if you have slow reaction time? And then now it says that we have 10 people, and then each one has the same probability of being in group X. And then what's the probability of at least 2 of them being in group X? So in other words, probability of at least 2 then, I don't know, let's call this like W. And then W is binomially distributed, and there's 10 people, right? And the probability of one person being in group X, because, they all have slow reaction times. That's what it tells you. All 10 people have slow reaction times. So this is the probability of one person being in group X. Okay, so there you go. So what we can do is we can first, this is a cumulative binomial function, right? Because we want to add multiple instances of W. It can be 2, it can be 3, it can be 4, all the way to 10. So this is a binomial CDF. Cumulative. However, just like with the inverse, cumulative distribution, at least in the TI-84, is upper boundary. This is a lower boundary. So first we need to change this to 1 minus P of W being less than 2. So again, the complement of greater than or equal to 2 is 1 minus less than 2. But because this is talking about, you know, people, then less than 2 is the same as being equal to or less than 1. Okay, so we can calculate this. So in other words, our answer is 1 subtract the binomial CDF for this. So 1 minus distribution, go all the way down, binomial CDF. We have 10 trials. The probability of each trial being slow is right here. And our x value is 1. So press equal, and then here's our answer. 0.01096. You round it to 3 significant figures, then it's 0.011. This was a pretty tough question. Oh, did I close my Discord? Okay, Max fixed the issue. I don't know. Max is fixing the issue. So now people are complaining in my chat about things they had to learn last year that don't even matter anymore. Yeah. Well, to be fair, like I said, a lot of things got cut out from the SL curriculum. Vectors was one of them. The ambiguous case of Sine Law was another. So, you know, at the time that she was teaching you, we didn't know the new curriculum yet, so we had to teach you it. Just in case. We didn't know. So you can't blame her. I'm already on the last question. Okay, resizing done. So, consider this function from -2 to 2. And then here we have the region enclosed between the x-axis and then the function itself. This container is going to be modeled by rotating this region 360 degrees around the x-axis. So find the volume of the container. So this question, oh man, I don't even think I can do any of this. This first thing, volume of rotation, or something like that. This is no longer an SL, so not necessary to do. Okay. So next up, let's see if we can do this one at least. The volume in the water is given by this function. The rate of change of the volume of water is given by this derivative. And then the volume of the water is increasing only when T is between P and Q. Then we need to find the value P and Q. Okay, so this is easy. So increasing means positive. Positive derivative. So we can just graph this and then look at where it's positive. And I don't know why I keep going to the graphing calculator when I have Desmos, which is way faster. So 0.9 minus cosine, 2.5 cosine, 0.4 t squared. And this is from 0 to 4, so I can specify this is only going to be from 0 to 4. And it looks weird because I need to make sure that I'm in radian mode. Okay, so pretty obvious where this is going to be positive. It's going to be between 1.374 and 3.564. So this is my P and this is my Q. So 1.734, 3.564. Okay. Now, during this interview, the volume of water is going to increase by a certain amount. Then we need to find the value of K. So that means that to find the volume, I need to find the area between here and here. So that's just an integral. So if I call this function x, then I can calculate the integral from this value, 1.734, to this value, 3.564, of my function. And there it goes into the calculator. Again, all of this is doable on a TI or any graphing calculator, but I just don't want to be clicking buttons around, you know? So 3.75. So again, integral of the function. And this is from P to Q. And I get 3.75 meters cubed. You're back? Where'd you go? Alright, and then final question. Hopefully I can do this one. When time is 0, the volume is going to be 2.3 meters cubed. And it's known that the container is never completely full of water during this 4-hour period. 4-hour period, yeah. And then find the minimum volume of empty space in the container. Okay. So the minimum empty space is the maximum volume of water, right? The most water you have means that's the least amount of empty space in the container. And they're saying that it's never empty or never completely full because then the minimum would be 0. Okay, so how do we find the maximum volume of water? Well, this is an optimization problem. So essentially, I need to solve g prime of t equaling 0, right? Now this is easy enough because I already did that. That was P and Q. Ooh, integrals. So fun. It's very simplified. They're essentially antiderivatives. You're going backwards. And then they represent a bunch of things. Area underneath a curve is the main one. Okay, so I have two critical points right here. And you can see from a visual first derivative test, my maximum volume of water is going to happen at this one, 3.54, because the derivative is positive before the critical point and then negative afterwards. So by first derivative test, it goes increasing and then decreasing. So this is a max. So Q is a local max. And you have to be careful because when you have boundary points, you also need to check that the boundary points you need to compare their volumes. Okay, so first let's write g of x. Oh, they never give me the function g. Oh, when time is 0. This is the volume container. Okay. Excellent. Okay, so this is one of our possibilities, right? Of being the absolute maximum, because we know it's the local maximum. However, we need to check boundary points. Now, the only way we can do that is if we can plug our t values in to g, but we don't know g, we know g prime. So we're gonna need to take an integral. Posture check. Ugh. So first, I'm gonna take a general integral, indefinite integral of g prime. So this is the integral of 0.9 minus 2.5 cosine 0.04 t squared Do I really need to do this? I guess I should, just in case. Okay. So taking this integral, 0.9 becomes 0.9 times t. So you see snake start, this is kind of how you calculate integrals. The integral of 0.9 is 0.9t, because that's the reverse, the antiderivative, the reverse derivative. I'm essentially finding out something that if I take the derivative, I get this answer. So the integral of 0.9 is 0.9t. And then this one is more complicated, so don't worry about it. Can I even take the integral of this right now? No, I don't think so. Do I need to do this? Who knows? I feel like I do. Yeah. Like, you should be able to take basic integrals because you know your derivatives. For example, what's the integral of 2x? It's more or less x squared. Because if you take the derivative of x squared, you'll get 2x. You just go backwards. Okay, so Q is the local max, is what they're saying. So to find the minimum volume of empty space, then what we do is we find so this is the maximum volume of the water. And then we know that at 24, at time 0, we have 2.3 meters. So then we take 2.3 meters and then we subtract the maximum volume of water. And then this should be the empty space, I think. Okay, so let's do that. Or we add these together. Yeah, we add these together. The beginning volume plus the volume from up until point Q. So from Desmos, I get 3.86. So like this is the starting amount, which is 2.3, and then, you know, after Q amount of seconds, we add how much water has been added in, which is this part. So now we've reached our maximum volume, which is our minimum empty space. And then I'm done. So not bad. Basically 2 hours in. Took a little detour and did some help. And I think you're... Well, okay, and then I skipped some questions, so that's why I'm kind of at a good time. But let's check our answers to everything that we have done. Sundays are always pretty slow compared to the Thursday stream. Okay, let's see. 17, 17, 18 over 35, 18 over 35, 24 over 35, 24 over 35. Okay, 6 marks, easy peasy. Okay, 9.91, 9.91, negative 31.5, negative 31.3. Oh, that's a 3. Okay. My R value, 986, 986. Then 181 centimeters. Same thing. And then, okay, you stick with 3 sig figs, so you round it up to 182, sure. Okay, Y-intercept at negative 1/3. negative 1/3. See you later, Snake Star. Thanks for tuning in. Equation of vertical asymptote, negative 3/2, negative 3/2. Did I even help you today? Sure, you're welcome. Let's see. Y equals 3, y equals 3. The limit is 3, the limit is 3. Easy peasy. 2.95, 2.95. 659, 659. 5.35, 5.35. 0.4.6, 0.4.6. K is 4, K is 4. Oh, this weird one. The first one was a show, so I showed it. And then the second one, we checked the answer key because it was really weird what they wanted us to do. So that one's fine. This was the vector question. Okay. And then 107, 107. Looks good. Standard deviation 220, 220. That's good. Oh look, they even do the tree, same as me. Okay, 163, 163, so that's good. Uh, 110, 110. Nice, 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 nice. Okay, skip the first question. 173, 173. 356, 356, that's good. 3.75, 3.75. And then okay, 0.85. Oh, we have this. Oh, whoops. Right, they want to find out the minimum amount of space, and what I just found out, this is the maximum amount of water. So, how much does this container hold? Oh, that was in part A. Whoops. So, I guess I couldn't completely finish this question, because then I do the volume minus 3.86. And then I'll get the actual final answer. Oh well. I don't think that counts because you needed to do part A and I skipped part A because it's not part of SL curriculum anymore. So overall, a solid 7. Guaranteed. Easy peasy. All right. So let's see what's going on with this Discord. Nothing much. Still very happy about this fan art. No one's been posting memes. No one's been posting pet pictures. And someone posted a picture of me. I don't even remember when this is. But this is to make an emote on our channel. And Maxime added an anime discussion board. I don't know why. You guys know how I feel about weebs. But there you go, guys. Sunday stream done. Finished another paper. Not even in... What do you mean? I'm not even in my own server? I'm in my own server. Are you in the server? Exclamation mark Discord. You can join. I think the link underneath my stream in my channel, I need to update it. It's broken, but that link works in the chat. Yeah, I don't know why I made an anime discussion channel. Do I play chess? No, I do not play chess, Batster. It's gonna be a bunch of kids Naruto running in digital Discord format, posting cringe JoJo memes and all of those other things. I think that's why he made it, because he knows that I wouldn't be happy with it. Oh well. I'm gonna call it here, guys. Thanks for tuning in. Yeah, I don't know. I'll see you guys on Thursday when I stream next time. See you later.